A switch is a central connecting device that all computers connect to in a wired fashion. This is a design known as a star topology. A switch sends the signal, the frames of data, to the correct computer on the correct port. And it does this by identifying the MAC address of each computer. This can effectively make every port an individual entity. So here we have a switch, and let's say we had a computer connected to port 1. You would connect with a patch cable and an RJ45 plug on the end. And when you do so and connect the other end to the computer, you'll see that connectivity. The LED, the link light, will light up on the switch, and it'll light up on the computer's network interface card. If we had other computers connected, and that's the whole point, let's say we had other computers connected here, those computers can all communicate with each other via the switch. Now, switches employ a matrix of copper wiring instead of just a trunk circuit in older hubs. So these have a matrix, so every port can communicate with every other port simultaneously. They're also intelligent, and they use this intelligence to pass information to the correct port. This means that each computer has its own bandwidth. For example, 1000 megabits per second. You might also see 10 gigabit per second connections. And you might also see these written sometimes as, say, 1000 MB and a slash and an S. And that's the same thing, though. That's going to be the same as Mbps. I use this terminology, this measurement, because some of the big companies like Cisco use these quite often. So quite often you'll see 1000 megabits per second, which is 1 gigabits per second, and also 10 gigabit per second networks. You might also see 100 megabit per second connections, older connections, but you'll probably want to upgrade those switches if you do see those. Switches work within the Ethernet standard. That's the most common networking standard used today, and it was ratified by the IEEE, and it's documented in the 802.3 set of standards. For example, a typical Ethernet network running at 1000 megabits per second and using twisted pair cable is classified as 802.3AB. And if it's running at 10 gigabits per second, again over twisted pair cable, TP, then it would be known as 802.3AN. But they're all within the 802.3 Ethernet standards. Quite often, multiple switches will be used because you can only connect so many computers to one switch. In this example, we can only connect 16 systems. You can get switches with more ports. You can get 24, 48, 96, and so on. But at some point, you're going to get to a max. So quite often what you'll see is you'll see the switches connected in a hierarchical fashion. And what that means is you'll have computers connecting to a switch, computers connecting to another switch, computers connecting to another switch, as many switches as you need for those systems. And then those switches will connect to a master switch. So we have the star topology where computers are connected to a switch, and the switch is the central connecting device for those computers. But then we do this in a hierarchical fashion where each of these switches connects to a master switch. So that's very common. Let's take a look at a switch that I have here. And this is a Cisco SG200. So we're going to log into this guy now, and you do that through the browser. Now, in the A+ exams, you're not going to need to know Cisco commands in the command line, like the show command and things like that. I'm going to show you a switch that's operated from the GUI. Now, you'll notice here that I connected by IP address 10.252.0.240 within the browser, and it says it's not secure. So keep that in mind. So we'll log in now. And notice that you can log in, or you can log in with secure browsing, HTTPS. Really, we don't even want that option. So we're going to show how to turn that on so it only does secure browsing. But right now we're going to log on in an insecure fashion, so to speak. And so the first thing I want to show here, you can see there's lots of configuration that you can do here. But let's look at the basics. I want to show the IP address configuration screen for this switch. So we'll go to Administration, Management Interface, and IP version 4 interface. When we do that, we see the IP address of this switch, and that is what we connected to. Now you have two options here. You have dynamic and static. A dynamic address means that the switch will look out to the network for a DHCP server to obtain an IP address automatically. Generally with switches and servers and things like that, you don't really want to go that way unless you have a lot of switches. So if you have one switch or a couple switches or several, static is the better way to go so that you know and you can do documentation on this specifying what switch uses which IP address. And that's what I've done here. I've made it static and set it to .240. And there's all kinds of other information here. You can create additional user accounts. You have a system log, diagnostics, and so on and so on. One thing that you'll get into more if you get into the Network Plus and Security Plus will be VLAN management, spanning tree, and especially security. Now let's take a look at security. Lots of stuff here. And we'll go to TCP UDP services. And here we see we have the option to connect via HTTP and HTTPS. And if you look down here, we do have an HTTP connection to this address. The local address is .240 from .254. That's the workstation I'm working at using inbound port 80. So that's what we kind of don't really want. We want to connect to this in a secure fashion with HTTPS. So to only connect via 443 instead of connecting on 80, to only use HTTPS, we'd have to disable HTTP and then apply that. Now, before we could do that, we would have to actually have a valid certificate and have that set up in the SSL server section. That takes a little bit of doing with the Cisco switch, and it's really beyond the scope of the A+ exam, but that's what you'd want to do so that we could just have HTTPS and connect in the browser with a valid certificate and get that padlock. Other than that, you could also use SSH, and you could configure that for connectivity, and you have your user and server authentication here. So there's a lot of options when it comes to security, but that's a little bit about the switch here. Now, I showed before, if you have these switches connected in this manner, you have a hierarchical connection. But what if someone was to connect these two switches together or these two switches together? Then we could have a loop, and the information would constantly be going round and round in circles because of that secondary connection between the switches. So you want to avoid looping, and to do that, you implement something known as spanning tree protocol. That's STP. And that can be found here, spanning tree, and we'll go to STP status. And you want to make sure that the spanning tree protocol is enabled, and generally that's set to rapid STP. So even if someone was to connect these switches in a physical manner, in a secondary fashion, and it creates a loop, that loop would be blocked by STP. So that's a little bit about network switches. And the cool thing about this SG200, I'm actually using a physical box, but this is available as an emulator on the internet from Cisco. So you can check that out for free also and check out some of the configurations. All right, so definitely take a look at that and take a look at any switching that you might have in your household or in your network if you have rights and permissions to do so, and learn a little bit more about network switching. And that's about it for this video.